Hey there, calculus fans. Continuing my Math 124 Exam 1 review video. I just worked through about half of an old exam. I just, and I'm going to do the other part. In the previous video, we basically did a brief review of limit. So we hit some questions where we did that, and derivative rules. And so this part will be about the other stuff that comes into play, because we'll do some of the other problems. I do want to remind you that you can always go to my materials page. If you can't find it, you just need to search for Andy Lovelace. Of all the Andy Lovelaces in the world, I have the biggest website. You can go to Rate My Professor and see what an idiot I am, according to everybody. But you can click on Math 124. And I have all sorts of different review materials I've just made over the years. I've been here too long. But if you're having trouble with tangent lines, so part of what you need to do is be looking through lots of old exams, figuring out where your errors are, and that's easy. You could get a notebook out and you could look through 5 exams in like 10 minutes. And at the end of that, you'd be like, okay, these are the things I don't know how to start. So we're going to work through the rest of this exam. I would encourage you to try it on your own and then come back and check this. And I'll check things against my solution to make sure I don't make some serious gaffe. But we've already done all these questions, and so I'm going to move on to the last 3 questions. Okay, so here we go. We already did that. We did that. So here we have a graphical question. This is kind of foundational, seeing if you understand. Part of what we've done in the first couple weeks of our calculus course is just give you the tools to talk about the features of a graph that we might need. So here I have this function. It's got a little, bump in it here, a little hole, and we want to say some things about it. So first off, students should know that if you have the graph of the function, it's the height. I've been surprised sometimes that not everyone knows that. Meaning, if I said, what is f of 2? You should know that it's how far you go. I've been surprised sometimes to find that students know how to find the equation of a line, but they don't realize that that equation gives the height. So very important that we know that skill. Okay, f prime of x is the slope, and when I say slope, I mean slope of the tangent line. Together, those form a powerful tool, but in particular, the slope right there is 0. So they give me different information about my graph. This gives me the height, this gives me the slope. Calculus students have to know that. Part of what you've been doing is learning how to find the formula for the slope, but then once you can find it, it just gives you this incredible extra tool to answer questions. Okay, so find when the slope is 0. The only place, the slope is 0 at x equals 2 for sure, but it's also 0 everywhere over here. So also when x is less than -2. So I suspect that was the answer. We don't say the slope is 0 here. We say it's undefined, and we also say it's undefined here because the slope is different from the left and the right. So we say it's not differentiable, which is the big long word that's hard to say. Not differentiable. Okay, find the values of x at which it's not differentiable. Oh no, I just gave it away. At x equals 1 and x equals 0. I believe we all got to think of the, yes, so it's also not differentiable at -1. It has to be continuous in order to be differentiable. I should have prepared this. It's been a few years since I taught this course. I forgot one. This is why it's good for me to check. So, kind of the layer of definitions, it has to be continuous to be differentiable. It is not continuous here. Not continuous. But you've played this game in the homework. Oh, I can't spell continuous. And then we have one other place where the slopes don't match. So I wouldn't have gotten that right. Okay, next one. Compute the limit as x approaches -1. And this is just asking us a few different questions at once. So first it's saying, what happens to the function as you get close to -1? Well, it gets close to 4. You can see that. And that's part of the limit notation, is to give us a way to say what we're seeing. Without the limit notation, we wouldn't have a nice way of saying that. What about the next one? Well, if I plug in a -1 here, same strategy, it's a finite limit. Watch my previous video. I get 6 over secant, you might say, I don't know what secant a negative pi over 6 is. So then I say, well, do you know what cosine of negative pi over 6 is? And you say, well, I don't know that either. Yeah, well, you're in trouble. And then I say, do you remember this unit circle? And that pi over 6 is right here. Do you know what this is? And they say, I don't know. And I say, well, one of them is the square root of 3 over 2, and one of them is 1/2. So all you got to do is find a quarter, flip a coin. If it's heads, do square root of 3 over 2, and if it's tails, do a half. I'm joking. Don't do that. But you ask yourself which one's bigger. And I know this is bigger, and I know when I'm at 30 degrees, this is bigger than this. But you could also have that on your note sheet. Cosine is the x value. If you're going to negative pi over 2, the x value is the same. That doesn't change. And so it's 1 over square root of 3 over 2. Or, so what am I saying? I'm saying this is 2 over the square root of 3. So this is 2 over the square root of 3. And I'd multiply top and bottom by square root of 3 because I hate having fractions inside of fractions. And so this would be 6 square root of 3 over 2, which would be 3 root 3. So that one I could just plug in. I was partially testing students on whether they could compute. And I think they were mad at me about it. Okay, and then when we plug in a negative 1 here, this is one of our special limits. We should know that as this approaches 0 and that approaches 0, this approaches 1. That's a very important limit that you did when you were doing the derivatives of sine and cosine. Sorry, so let's pull that up. So that was a sneaky one, but limit strategies. Okay, graphs and limits. If this is something I would have students look at if they don't know their limits very well, but really knowing those 8 graphs is helpful. But this sine of x over x is an important special limit. Okay, so what am I getting? I'm getting 5 plus 3 root 3. I do want to say on these graphical questions, sometimes students just give up. You should treat each part as independent. Don't give up because you messed up, an earlier part. Let's pull this back up. See how we're doing. You don't have to say do as you do it. That's just an old weird man thing. Okay, so and then let's go to the next one. Find this. So this is more of a symbolic question, just to see if students understand what you would do. So if you had a function on top and you had an x squared on bottom, and they asked you for the derivative, what would you do? You would do the quotient rule. Denominator times derivative of the numerator minus numerator times derivative of the denominator. And because it's an f of x, sometimes that bothers people, but we need to be able to still follow the rules, even if something looks slightly different. So denominator, derivative of the numerator is just f prime, minus the numerator, derivative of the denominator is 2x, all over the denominator squared, which would be x to the 4th. Now the question is asking what happens when you plug in a half. And if you plug in a half, you get 1/4 f prime of a half minus f of a half times 1 over 1/2 to the 4th. So some students are like, well, how am I supposed to do that? And this goes back to understanding what things mean. The function f of x is the height, f prime of x is the slope. We're talking about 1/2. At 1/2, what is the height? It's 5. What is the slope? Well, we're going from 0.6 to 1.4. So we went over 1 and down 2. So the slope is -2. So this is -2, and this is 5. And so our final answer is going to be 1/4, -2. I know there's a lot I did there, but I'm just trying to give a broader picture of what I'm looking at. And we can simplify that -1/2, but I feel like I'm already... I was about to say I feel like I'm already losing people, but no one made it this far into the video, so I can't have lost anybody yet. If there's no one here. Oh, 2 to the 4th is actually 1/8. Is it 1/8? Oh, I see one of the x's cancel. I simplified. Okay, I think we have the idea. Let's keep going. So then we have a continuity question. These ones in particular, I feel like they kind of worry students, but I think it's very clear what you need to do, which is you need to make things line up at the places where they change. You need to make them the same at 1. You need to make them the same at 3. So you should just plug in a 1. Now you can think of it in terms of limits, and we may have to. If I'm being really formal, let's think about what happens when x gets close to 1 from the left. But all I'm really saying is, what happens when I plug in a 1 there? Well, I get b plus 3a minus 10. So if I were graphing this thing and I got close to 1, I know what the point will be. It'll be 1 comma b plus 3a minus 10. And I've got whatever's happening, this function over here. This is not the right picture. I want to make the other side line up with it. How do I make that happen? Well, now I need to think about what's happening as we approach 1 from the other side. Well, then we're using this formula, a minus b minus 2. And I want those to be the same, so now we have a fact. And I find that students don't have the right mentality here. We should feel really good about this. We have 2 things we're trying to find, and so we should be searching for 2 equations, and we already have 1. And in fact, you could simplify it more, but let's leave it there for a second. Now we need 1 more fact, and we'll be there, and you probably can guess what the other fact is. It's at 3. So now when we plug in 3 to both sides, what happens? So if you plug in 3 on the left, you're going to get 3a minus b minus 2. That's plugging in here. What about this one? You can't plug in 3 because you get 0 over 0. So here's when we need to consider the limit as we approach 3 from the right of x squared minus 9 over x minus 3. That's a 0 over 0 case. And so we start to try to do algebra so that we can cancel the denominator. And in this case, it's a pretty direct limit to do because you can do x minus 3, x plus 3, x minus 3. They cancel. You plug in 3, you get 6. This is 6. So now we're done. Your goal is to combine these at this point, and you'll be able to check your work and make sure they actually work. Okay, from the second equation, I get 3a minus b is 8. I get b, maybe 3a. At this point, there's so many ways to go. But probably I would solve for b and write b is 3a minus 8. And then I would shove this in here. I probably would simplify equation 1 first. I have found over the years that this is a part that people get mixed up on. The part that really bugs me is I'll see people just like randomly set things equal. The technique is to substitute. That's always the technique. That doesn't change. Even if you solve for both, you're still substituting. So we're just trying to get to a point to substitute. If you can see a way to simplify before you substitute, fine. But once you have it down to where you can substitute, you're trying to get it down to where you just have 1 variable. So when you're solving for 2 things, you're trying to get 2 equations. The moment you get those 2 equations, you're trying to substitute so that you have 1 equation with 1 variable. That's the idea. I'm always surprised that some people don't have that idea. A has to be 3. Once I know what A is, you can go back and plug it in everywhere and make sure you get the same B. And in this case, B is 1. And then you can go back to the beginning and you can check. So what I like about these is it's checkable. Now I'm going to check the way you shouldn't check, which is with the solutions, but 3 and 1. So those questions I remember students struggling with, but I always thought, if you have the idea, these are a lot better than a lot of the other questions. Using the values you just got, is the function differentiable at 1? So that's asking if the slope is the same at 1. Well, let's see. We now have the 2 functions. Before you get to 1 on the left, it's going to be b is 1. So x squared plus 9x minus 10. I just plugged in those numbers. So the derivative is going to be 2x plus 9. And if you plug in 1, it's going to be 11. So from the left, the slope is approaching 11. What about from the right? Well, on the right side of it, the function is ax minus b. So let me just write it out here. 3x minus 1 minus 2. So it's 3x minus 3. What's the derivative there? It's 3. Is 3 the same as 11? No. Not differentiable. So their slopes aren't the same. On one side the slope's 11, on the other side the slope is 3. Is that what I said? They don't match. 3 is not 11. Okay. So then we get into these applied questions. Let's see. I love these questions. I'd always like to have students throwing things at me, but a water balloon is thrown upward from a dorm window. It goes up for a bit, and then ultimately it falls down to the ground and coincidentally hits your math instructor. I'm going to make some videos that go with this where my kids drop water balloons on me, so stay tuned for that. I want to recreate these exam questions. The height of the balloon, this is this. What is the average velocity? So average velocity is something you did earlier in your homework. Sometimes students forget this, but this was a foundational idea. So it's just plug and chug. I think I'm not even going to show that. It's going to be something minus 80 because I can plug in the 0. We'll look it up in a second. Here we have a foundational question. What I like about these questions is you already know what the derivative is because at this point in the term you've already learned derivatives. And so you're going to be able to check your work. But let's go through and do it. So we're going to plug in t plus h to the function everywhere there's an input. That's what s of t plus h is. And then we're going to plug in a t everywhere there's an input. That's what this is. And then we're going to divide by h. And there's several mileposts along the way that tell us if we've made a mistake. First milepost is everything here should cancel. Second milepost is this should cancel. If those things don't happen, we've done something wrong. And in the end, when we plug in h equals 0, we better get this. So I know there's lots of places people make algebra here, and students are like, I always make silly mistakes there. But you have all these little checks and balances you can use along the way to see that you're doing it right. So 2th plus h squared plus 8t plus... And it looks bad for a second. As I like to say, we're going to take a sad song and make it better. That's a song that my students don't know anymore. And it's sad. And the song's before my time, but let's take a sad song and make it better. Let's do some wholesale cancellation is the other way I say it. This actually cancels with that. I usually distribute first because some students can't handle that. But I think you can if you're watching this video. Okay, so then we need to distribute negative 32th minus 16h squared plus 8h over h. And then I always tell students, which h do you cancel? The first one, the second one, or the third one? Got to be one of them, which is a trick question because you cancel all three. You should divide each term by h, which gives you negative 32 minus 16h plus 8. And then when you plug in h equals 0, it's this. Yay! So we shouldn't miss that. Okay, what is find the instantaneous velocity as it hits the ground? Hits the ground. How do we do hits the ground? We have these two things. We have the formula, which is 80 minus 16t squared plus 8t, and that's the height. And then we have the derivative, and that's the velocity, or the slope of the graph. So hits the ground is talking about height. It wants to know when the height is 0. And then we want to know the corresponding velocity. So what we're going to do is we're going to solve for t, quadratic formula, negative b plus or minus square root, b squared minus, oh no, I'm going to post a video where I sing, don't tell anyone, b squared minus 4ac all over 2a. You calculate it once you have the time, you plug it back in here. Looks like one of the times is positive, one of the times is negative. The units are going to be, what are we at? Feet per second. Let's go take a look at how I did. All right. Yippee. Solving gave me 5 halves, 2.5. I plugged it in. Done. Okay, so that's that thing. And then we have this, it appears, tangent question. So let's finish with that. And that'll kind of hit home the last of the topics. Find all points where that has a horizontal tangent. Oh, that's a standard question. It's a quotient rule question. We have a numerator. We have the denominator. I always remember it alphabetically. dn prime minus nd prime. I've had tons of students tell me I should teach people low d high minus high d low over low squared, but to me that is harder for me to remember. So I don't do that. But it doesn't matter. You can use whatever you need, but we do need to know what it is. Okay, so what I tell students also is you should do a visual inspection that your derivative is correct. And that's easy to do. Denominator, denominator. Minus, derivative of the numerator is 2x. The numerator is x squared. The derivative of the denominator is 3. The next piece of the puzzle is the question's asking us, when is this 0? This is one of these situations that if you think that's hard, you're misunderstanding. Because in order for this to be 0, the numerator has to be 0. So you multiply both sides by the denominator. And so we're pretty much there already. But I think I have one other thing I'm going to say here. Before I even simplify, let's think about the goal of this question is to solve. If you already have one side as 0 and your goal is to solve, it's almost always better to factor. So I'm going to factor right now. Just a random thought. If you expanded first, that's fine too, but you missed an opportunity. Notice there was an x here and an x here. Okay, so then you have x and you have 6x minus 12 minus 3x. I have this mantra of factor first. Whenever possible, and you have the other side as 0, factor first. I think if it has the 0 holds this power, you don't want to give it up. If you can factor and make something 0, you want to, because that breaks your problem into two cases, which breaks things down much more. So there's only two answers, 4 and 0. The question asks for the corresponding y value, but you plug it back in. If you plug it back in, the y value is 0. If you plug 4 back in, 16 over 6. 16 over 6. Let's check the solutions, make sure I didn't do anything ridiculous. 16 over 6 is 8 over 3. Alright, last question. Find all points on the curve where the tangent line is also through this other point. We like questions like this. It's this idea of, what if there's this road or something? And this is maybe, I don't know, looks something like this. Let's just pretend. I'm not trying to make it accurate. And you have some point. Well, now that I am worried my graph is so inaccurate. Oh, shoot. It's positive. All right. You have some point and you want to hit it. Now, if you were driving along this, there would be a moment where your headlights would shine on this person that's hiding here, waiting to throw a water balloon at you or whatever. Can we find it? So this is a question about conditions. It's the same sort of idea of a previous problem, which is we're trying to find two things. We need to write two conditions. So the main idea is we need to label this A, B. So let's let A, B be on the curve. And let's have it be the point where it's tangent. So in these problems, you should already have this plan when you go into the test. The fact that it's on the curve gives me one fact, which is that B is equal to 5/3 A plus 4A cubed minus 17. So it's important you understand that you're going to say, I don't know the point on the curve. They told me a point that's off the curve, but the line goes through it. Then we're going to consider slope. And it always is these two things. Because you have 2 points, you know the slope. The slope is B minus 10 over A minus 0. You can also write it as 10 minus B over 0 minus A. So this is the slope. But there's another way to express that slope because it's a tangent line right here. And so we would like to say the tangent line at A. And the tangent line is going to be y prime, which is the slope of the tangent line, is going to be this, 12x squared. And I would like to know the slope of the tangent line, particularly at A. So this all stems off this fact of labeling your unknown, a very powerful algebra technique. a problem-solving technique that students often miss. If you don't label your unknown, I don't know how you do this problem. So here was the idea. There's the slope of the line connecting the 2 points. That's how we're using the point 0, 10. Here's the slope of the line because it's tangent at A, and it's on the curve. And the moment I write those things down, I know I'm done. Algebra doesn't scare me. I had 2 things I needed to find. I have 2 equations. I'm going to slap them together and get it. Now, my personal preference, and I don't know what the best process is. I don't like fractions when I'm about to start solving. I probably would multiply everything by A, and I'd multiply everything by 3. I really don't want to have fractions. But let's just multiply everything by A for a second. A cubed. And then I'm going to combine these 2 things. So your goal is first to get conditions and then get down to 1 variable. That's a general idea of when you're solving for constants, which I find that a lot of people don't have. And so I take it as a mission to talk about it every single time it happens. It's a fundamental idea of algebra and solving. So now we're trying to solve this. This happens to be nice. It better be, or else I don't know how we do this. You can subtract that from both sides. You can subtract this 4, and you're going to get 8a cubed. And here you get negative 27. And so you get negative 27 over 8 is a cubed. And a must be the cube root of that, which would be negative 3 over 2. Find all points. There's only one. It's when a is negative 3 over 2. And if you wanted the b, why did I ask for the b? Dr. Lovelace is a jerk. I don't think I would anymore. This is a pain to get the b. But it does come out kind of nice. I just was being lazy. All right, please let me know if you found that helpful. I'm thinking about doing a Zoom review session where you could join me. Now, if I did that, I wouldn't be able to probably get to everyone's questions, but the idea would be just to let you hop on, ask me a few specific ones, and remind you of content. But I wanted to make something like this that I could post forever, because I think this exam gives a pretty good picture of what Exam 1 and Math 124 is like. And I hope you're getting the sense it's a few particular skills. It's not as bad as that you might first think. And if you need more practice with those individual skills, I've made all this stuff. And you can get plenty of practice. There's just a bunch of problems of finding the equation of the tangent line. Okay, hope some of that is useful. Give me a like or subscribe if it is. All right, thanks.